Hello, and welcome to Lesson 8 of the Big Data and Hadoop Developer course offered by Simplilearn. This lesson focuses on Hive. Let us explore the objectives of this lesson in the next screen. By the end of this lesson, you will be able to describe Hive and its importance, explain Hive architecture and its various components, identify installation and configuration steps for Hive, describe the basics of Hive programming. In the next screen, we will discuss the need for an additional data warehousing system. Anyone who owned and operated a web application would be familiar with the problem of the storing and retrieval of data being generated every minute. The adaptive solution created for the same was the use of Hadoop, including the Hadoop Distributed File System, or HDFS, for performing operations on data for storage and retrieval. The Hadoop framework has a scalable and highly accessible architecture. Another problem that cropped up further in the process was that some data could not be expressed. It was difficult to develop a map-reduce program for expressing the data. The solution was Hive. In the next screen, we will discuss the basics of Hive. Hive is defined as a data warehouse system for Hadoop that facilitates ad hoc queries and the analysis of large data sets stored in Hadoop. It provides a SQL-like language called HiveQL or HQL. Due to its SQL-like interface, Hive is a popular choice for Hadoop analytics. It provides massive scale-out and fault tolerance capabilities for data storage and processing of commodity hardware. Relying on MapReduce for execution, Hive is batch-oriented and has high latency for query execution. In the next screen, we will discuss the key characteristics of Hive. Hive is a system for managing and querying unstructured data into a structured format. It uses the concept of MapReduce for the execution of its scripts and HDFS for storage and retrieval of data. Following are the key principles underlying Hive. Hive commands are similar to that of SQL. SQL is a data warehousing tool that is similar to Hive. Hence, learning Hive will not be a big challenge for those who are familiar with SQL. Hive contains extensive pluggable MapReduce scripts in the language of your choice. These scripts include rich user-defined data types and user-defined functions. Hive has an extensible framework to support different files and data formats. Performance is better in Hive since Hive Engine uses the best inbuilt script to reduce the execution time, thus enabling high output in less time. In the next screen, we will discuss the system architecture and the components of Hive. The image on the screen shows the architecture of the Hive system. It also illustrates the role of Hive and Hadoop in the development process. In the next few slides, we will discuss the components of Hive as shown on the screen. We will start with Metastore in the next screen. Metastore is the component that stores the system catalog and metadata about tables, columns, partitions, and so on. Usually, metadata is stored in a traditional RDBMS format. Apache Hive uses Derby database by default. Any JDBC compliant database like MySQL can be used for Metastore. In the next screen, we will discuss the configuration of Metastore. We will focus on the key attributes that need to be configured for Hive Metastore. The primary attributes that should be configured are connection URL, connection driver, connection user ID, and connection password. Now let us look at the XML file used to configure Metastore. The template of the file displayed on screen may vary from one version of Hive to another. In the next screen, we will focus on driver. Driver is responsible for managing the lifecycle of an HQL or Hive query language statement as it moves through Hive. The driver also maintains a session handle and session statistics, if any. It includes three basic components, namely the compiler, the optimizer, and the executor. In the next screen, we will focus on the compiler. Query compiler is one of the driver components. It is responsible for compiling the Hive script for errors. If the script is error-free, it is converted into a directed acyclic graph or DAG of MapReduce tasks. In the next screen, we will focus on the Query Optimizer. Query Optimizer optimizes Hive scripts for faster execution of the same. It consists of a chain of transformations, so that the operator DAG resulting from one transformation is passed as an input to the next transformation. A query optimizer also performs tasks like column pruning, partition pruning, and repartitioning of data. In the next screen, we will discuss the role of Execution Engine. The role of Execution Engine is to execute the tasks produced by the compiler in proper dependency order. The execution engine interacts with the underlying Hadoop instance to ensure perfect synchronization with Hadoop services. In the next screen, we will discuss the server components in Hive. Hive Server is the main component responsible for providing a thrift interface to the user. It also maintains connectivity in modules. It provides a JDBC or ODBC server. JDBC stands for Java Database Connectivity, and ODBC refers to Open Database Connectivity. Hive Server enables the integration of Hive with other applications. In the next screen, we will discuss client components. A developer uses client components to perform development in Hive. Some of the client components are Command Line Interface or CLI, Web User Interface or UI, and the JDBC ODBC driver. CLI is the Hive prompt from where you can enter commands and execute the same. Web Interface is a web console to view and interact with Hive. The JDBC ODBC driver is used to interface Hive with the existing database components or engine. In the next screen, we will discuss the basics of Hive query language. Hive Query Language, or HQL, is the query language for Hive Engine. Hive supports basic SQL queries, such as the from clause subquery, ANSI joins such as equa-join only, multi-table insert, multi-group by, sampling, and objects traversal. HQL provides support to pluggable MapReduce scripts using the transform command. In the next screen, we will focus on tables in Hive. Hive tables are analogous to tables in relational databases. A Hive table logically comprises the data being stored and the associated metadata. Each table has a corresponding directory in HDFS. There are two types of tables in Hive. They are managed tables and external tables. To create a table in Hive, use the command shown on the screen. Once created, this table can be located in HDFS in a directory mentioned on the screen. In the next screen, we will focus on external tables. External tables are Hive entities that are similar to tables. The difference is that when a table is created, the unstructured data, which is linked to this table, is deleted. In external tables, however, unstructured data is copied and not deleted. Following are the key considerations in an external table. External table points can be stored in existing data directories in HDFS. External tables can create tables and partitions. In an external table, data is in Hive-compatible format. When an external table is dropped, only the metadata drops. Let us consider an example on how to create an external table. The command used to create an external table is called test_extern, using unstructured data available at the location mentioned on the screen. While the table is created, it is ensured that the data is not deleted. In the next screen, we will discuss data types. The data types in Hive are primitive, complex, and user-defined types. Click each box to learn more. Primitive data types include integers such as tiny int, small int, int, and big int. Boolean, floating point numbers types such as float and double, and string. Complex types include structs, maps, and arrays. Examples of such types are shown on the screen. User-defined types include structures with attributes that can be of any type. In this screen, we will discuss partitions. Partitions are analogous to dense indexes on columns. The features of partitions are that they contain nested subdirectories in HDFS for each combination of partition column values and allow users to retrieve the rows efficiently. An example of a partition is shown on the screen. Let us now focus on how to create a partition in Hive. Certain queries are used to create partitions and insert data in them. Some of these queries are given on the screen. In the next screen, we will discuss serialization and deserialization. Serialization takes a Java object that Hive has been working with and turns it into something that Hive can write to HDFS or another supported system. Serialization is used when writing data, for example, through an insert select statement. Deserialization is used during query time to execute select statements. The other facts related to serialization and deserialization are: the interface used for performing serialization and deserialization is serd. In some situations, the interface used for deserialization is lazy serd. This interface allows unstructured data to be converted into structured data due to its flexibility. While using this interface, the data is read based on the separation by different delimiter characters. The serd interface is located in the jar file mentioned on screen. In the next screen, we will explore the file formats in Hive. Hive lets users to store different file formats and helps them to improve the performance with respect to the operations done on data, such as storing, analyzing, and so on. The example given on the screen shows how SQL is used to perform a file format operation in which the sequence file input format class is used for input and the sequence file output format class is used for output. In the next screen, we will focus on Hive queries. One of the queries in Hive is select. The syntax of the select query is shown on the screen. Similar to a relational database, the select query has where, group by, sort by, and limit clauses. The select query also supports nested queries. In the next screen, we will focus on join and insert operations. HQL supports join and insert commands. Some examples of join and insert commands are shown on the screen. In the next screen, we will discuss the installation of Hive. To install Hive, you need to locate the Hive-tar file. You will be using Hive version 0.13.1 for your practicals. You can also use the newer versions. You can get the download location by visiting the URL shown in the image here. In the next screen, we will download the Hive-tar file and untar the same. Use the wget command to download the Hive-tar file in Ubuntu system. Once the download is complete, you need to extract the Hive-tar file. The command for the same is shown on screen. In the next screen, we will continue with the Hive installation process. Move the extracted tar file to the location mentioned on the screen. Use the command displayed on the screen to perform this step of Hive installation. In the next screen, we will set the Hive prefix and the path for Hive. Ensure that you move the Hive folder, which was extracted in the previous step, to the location mentioned on screen. Next, you need to use the command shown in the first image to set the Hive prefix. To set the path for Hive, use the command shown in the second image on the screen. In the next screen, we will discuss how to start the Hive prompt. To start the Hive prompt, use the Hive command and press the Enter button. You will get a prompt similar to the one shown on the screen. Now let us focus on the properties that are set in your Hive system. To know the Hive properties that are set in your machine, use the command set -v. In the next screen, we will discuss how to perform programming in Hive. To show the total number of tables, use the Show Tables command. Ensure all commands end with a semicolon. Initially, you will get an output similar to the one shown on the screen. This is because currently there are no tables in Hive. So let us now create a table in the next screen. Suppose the name of the table is Book, and it has one column called Word. Use the command shown on the screen to create the table. Ensure you complete your query with a semicolon. In the next screen, we will take a look at the output. As discussed earlier, Hive stores a table in the form of a folder. To view the output, browse the Name Node Web UI and look for the directory named User. Under the User directory, you will find a folder named Hive. Under Hive, you will find a folder named Warehouse. In the Warehouse folder, you will find your table named Book. In the next screen, we will load the book from HDFS to the Hive table we have created. There is no content in the book. Let us now add some content from unstructured data. Ensure that you have the War and Peace book uploaded to HDFS. In the next screen, we will focus on the command used for this purpose. The command shown on the screen will help to load the data from HDFS. In the next screen, we will check if the table has been successfully created. To verify the same, use the command Show Tables in Hive prompt. If the listing shows your table, it means that the table has been successfully created. In the next screen, we will continue to focus on programming in Hive. Let us check the table schema in Hive using the command shown on screen. In the next screen, we will discuss how to check the content of the table. Use the command given on the screen to check the content present in the table. You will get the output as words. In the next screen, we will focus on the extensibility of Hive query language. Use the command given on the screen to check the content present in the table. You will get the output as words. In the next screen, we will focus on the extensibility of Hive query language. The Hive query language can be extended in multiple ways. Some of the common ways include pluggable user-defined functions, pluggable map-reduce scripts, pluggable user-defined types, and pluggable data formats. In the next screen, we will focus on user-defined function. Hive has the ability to define a function. Any new user-defined or UDF class needs to inherit from this UDF class. All UDF classes need to implement one or more methods named evaluate, which will be called by Hive. Evaluate should never be a void method. However, it can return null if needed. After compiling UDF, you have to include it in the Hive class path. Then, once Hive gets started, you have to register the function. Next, you use the function in a Hive query statement. In the next screen, we will focus on built-in functions. Hive provides a lot of built-in functions such as mathematical, collection, type conversion, date, conditional, and string. In the next slide, we will focus on other functions in Hive. There are various other functions in Hive, namely aggregate function, table generating function, and so on. Aggregate functions create the output if the full set of data is given. The implementation of this function is a little complex compared to that of the UDF. The user has to implement a few more methods, but the idea is similar. Therefore, Hive provides a lot of built-in user-defined aggregate functions, also known as UDAF. Normal user-defined functions, namely concat, take in a single input row and output a single output row. In contrast, table-generating functions transform a single input row to multiple output rows. Lateral view is used in conjunction with table-generating functions. An SQL script for lateral view is given on the screen. Consider the base table named Page Ads. It has two columns, namely Page ID, that is the name of the page, and Ad ID list, that is an array of ads appearing on the page. A lateral view with explode can be used to convert Ad ID list into separate rows using the query given on screen. In the next screen, we will focus on MapReduce scripts. MapReduce scripts can be written in scripting languages like Python. Users can plug in their own custom mappers and reducers in the data stream. To run a custom mapper script and a custom reducer script, the user can issue a command which uses the transform clause to embed the mapper and the reducer scripts. For example, in the script shown on the screen, by default, key-value pairs will be transformed to string and delimited by tab before feeding to the user script. The method strip returns a copy of all the words in which whitespace characters have been stripped from the beginning and the end of the word. The method split returns a list of all the words using tab as the separator. In the next screen, we will focus on the comparison of UDF and UDAF with MapReduce scripts. User-defined functions are written in Java, while MapReduce scripts can be written in any language. Both user-defined functions and MapReduce scripts support one-to-one, n-to-one, and one-to-n input to output. However, user-defined functions are much faster than MapReduce scripts, since the latter spawns new processes for different operations. In the next screen, we will focus on a business scenario. Olivia is the EVP IT Operations at Nutra Worldwide Incorporated. Clive is the AVP Business Interface. Clive is assigned to one of Olivia's projects. He has been asked to analyze the distribution data at Nutra Worldwide Incorporated. As part of this assignment, he has to perform advanced data analytics. Clive wants to install Hive so that he can perform data analytics. The demos in this lesson will illustrate how to install Hive and perform data analytics and partitioning. We will start with the first demo in the next screen. In this demo, we will perform installation of Hive on Ubuntu system. Visit the website www.hive.apache.org. Click the Downloads link http://hive.apache.org/downloads.html. Click on Download a Release Now link http://hive.apache.org/dyn/closer.cgl/hive/. Click the mirror link http://mirror.tcpd.iag.net/apache/hive/. Click Hive version 0.11.0 file. Right-click the Hive -0.11.0 tar file. Click on Copy Link Location menu item. Access the server shell prompt and download Hive. The command is wget followed by the link mentioned on the screen. Once downloaded, you will need to uncompress the folder. This is done using the command shown on the screen. Copy the extracted folder to the desired location. Use the command shown on the screen. The next step is to install Java. Type the command shown on the screen and press the Enter key to continue. Now let us set the bash. To do so, use the command shown on the screen. Scroll down and ensure you add the lines as highlighted in the screenshot. They are export hive underscore prefix equals slash USR slash local slash hive and export path equals $path $$hive prefix underscore slash bin. If you see an output as shown in the screenshot, it means that Java has been installed and configured successfully. Update the bash using the exec command. Ensure that Hadoop services are active. This can be done using the command jps. To start Hive, the command is Hive. You will get a Hive prompt where the queries are run. Congratulations! You have now successfully installed and configured Hive. Let us do a quick recap of the steps performed. In this demo, we will demonstrate advanced data analytics using Hive. For example, let us create a table called Book with one field of data type string. The command used is shown on the screen. Press Enter key to continue. Observe row format delimited. Press Enter key to continue. Observe fields terminated by single quotes. Press Enter key to continue. Observe lines terminated by slash and press the Enter key. Now let us load the data from the file into the table. The command to load data is shown on the screen. Press Enter key to continue. Let us verify the table by listing the same. The command is show tables semicolon. Press Enter key to continue. The highlighted part shows our table book. Let us verify the schema of the table book. The command is describe book semicolon. Press Enter key to continue. The output describes the table book. Type select lower open bracket word close bracket comma count open bracket asterisk close bracket as count and press Enter key. Observe from book and press Enter key. Observe where lower open bracket substring open bracket word comma 1 comma 3 close bracket equals start single quote was end single quote. Press Enter key. Observe group by word and press Enter key. Observe having count as greater than 50. Press Enter key. Observe sort by count DESC semicolon. Press Enter key to start the execution process of the query. Observe the job execution. Observe the output. It shows the occurrence of the word was, which is 366. Congratulations, you have now successfully executed the program. Let us do a quick recap of the steps performed. Let us look at the word count demo using Hive. To begin with, launch Hive on your system. Create a table named Book with a single column, text word, to store the contents. In this case, we will put all the contents of the table in a single column and do further transformation and querying. Use the syntax shown on the screen. The fields are terminated by /n since we are using a new line character as a delimiter to read each line. The file is saved in the text file format. The table book will be created once you press enter after semicolon on Hive prompt. Load the book Gutenberg.txt from the HDFS path. Use the syntax shown on the screen. Use the command shown on the screen. Enter semicolon and press enter. The contents get uploaded in the table book in Hive Warehouse. Query the table for determining the word count by using the select statement. Use the select query with the count operator. Use lateral view and user-defined functions to split the contents into space-separated words. A lateral view first applies the user-defined function to each row of the base table and then joins the resulting output rows to the input rows to form a virtual table having the supplied table alias. To put it simply, this line will put each word on a separate record of lateral view. Now, group by word so that the count operator can give the result by each distinct word. Execute the query and observe the result with each word showing the count of times it occurs in the document. In this demo, we will use a document from the document management system of Nutra Worldwide Incorporated and demonstrate how to determine word count using Hive. Let us do a quick recap of the steps performed. In this demo, we will demonstrate partitioning with Hive. Let us look at table partitions using Hive. To begin with, launch Hive on your system. Create a table president. Mention the two columns SNO, which means serial number and line, which includes the president name per line. Partition by the parameter country, which is of type string. Note, we have not mentioned country as a column in the table unlike we do in most of the relational databases. Use the usual Hive syntax row format delimited. The fields are terminated by a comma since the data is comma separated. Execute the query and use the describe command to verify if the table is created as per the requirement. You will observe that the table has been created successfully. Let us now load data in the table. Load data in the table president using the load data in path command since the data is already present in HDFS. You will observe an error if the partition is not specified. The reason for the error is that we did not specify the partition in which data is to be loaded. Let us try to rectify the error by using the clause partition country equals USA to ensure that data gets loaded in the right partition of the table. You will observe that query has been successfully executed. Let us check the data in HDFS to see how Hive tables and partitions are created. From the Hive prompt itself, use the command shown on the screen to view the table directory. Please note that the directory location may vary with Hive and Hadoop distribution version. List the directory for the partition country equals USA partition. Note that a directory is created for the table president. A directory is also created for the partition country equals USA. Let us now load the data for some other countries also. Let us load the data for the partition country equals India. Now load the data for the partition country equals Russia. Check how the various partitions have been created in HDFS. Use the dfs-ls command again from the Hive prompt. You will observe that a directory for each partition has been created. You can list the content of each directory to view the data files present in every partition directory. Let us do a quick recap of the steps performed. Let us summarize the topics covered in this lesson. Hive is a system for managing and querying unstructured data into a structured format. The various components of Hive architecture are Metastore, driver, execution, engine, and so on. Metastore is a component that stores the system catalog and metadata about tables, columns, partitions, and so on. Hive installation starts with locating the latest version of tar file and downloading it in Ubuntu system using the wget command. While programming in Hive, use the show tables command to display the total number of tables. In the next lesson, we will focus on HBase.